Hey guys, welcome back. So coming back to different types of decision trees. So there are basically two different types. Again, there are different. There are different types, but two main different types of decision trees are something which is called as card trees, right? It's called as Cartesian and regression trees. So card is nothing but your Cartesian regression tree. The other tree is basically your ID tree, right? ID type tree. Basically, how these two trees differ is basically the approach in which they use to create your splits, the approach in which nodes are created. So it's basically the approach in which your splits are created. And the first one uses something which is called as the Gini index. It uses a metric. Okay, it uses a metric called Gini index. The second one uses a metric which is called as information gain. These are so this is how these two trees are basically separated. Right? So we'll just basically go into discussing each one of them in detail. Understand how do we actually build a tree with a sample data set. Okay. So this is basically your sample data set. What this data set basically says is, so you basically have four columns: outlook, temperature, humidity, windy. Right? Outlook. So these are the four columns which are your x values, right? X1, X2, X3, and X4. And play is what you're trying to predict. So the basic idea is you're just basically trying to predict when you can play, when you cannot play. Correct. Right? That's what you're basically trying to predict. Right? Now say you're given this data set, right? You're asked to start building a tree, right? So the first step over here is you need to basically figure out what is the root node, right? See, root node basically is nothing but your column, right? Which column you should choose as the root node, right? So you basically have your outlook, you basically have your temperature, you have your humidity and windy. So you should basically choose one particular column as your root node. So see, you can choose outlook, you can choose temperature, you can choose humidity, you can choose all four. Right? So you obviously cannot randomly choose, because so now you're creating a root node for other splits also, right? Again, when I say splits, these are basically your other splits, right? Obviously, this is on a different data set, but the structure would be the same, right? So for other splits also, you should have some sort of logic, right? You should have some sort of logic in place. Obviously, you can't do it randomly. Then the whole idea of building a model is lost, correct? So you should have some sort of logic, right? So it's like you can't just have some generalized logic. You can't just have a logic specific to this particular data set only, correct? You should have a logic which is generalizable, right? So that is where your entropy, your Gini index, your Gini index or information gain comes in. Okay, that is where all of this comes in. So basically, what you do is at each level, right? At each level, this is one level, this is another level. At each level, basically, what you do is you calculate these metrics for each of these columns. Okay, and at that level, whatever column has the highest metric. Okay, say basically, say in the first level, you're not sure on what is your root node. So you have four columns. So basically, you calculate that metric. You calculate that metric for each of those columns, and the column with the highest metric, okay, and the column with the highest metric becomes your root node. In a similar manner for other nodes as well, you basically choose that column with the highest metric. Okay, so that is what is the idea behind using your either Gini index or information gain. Okay, so we'll actually look into one. We'll look into how mathematically what they are, because this is more mathematically based, mathematical formula based, right? So entropy, Gini index, all of that are it basically has your mathematical formulas, and we look into each one of that. But this is what that overall idea. This is what happens in decision tree, right? You have multiple columns. You need to figure out the root node. How do you figure out the root node? Basically, calculate some metric, right? You basically calculate a metric for each of those columns, for each of the four columns or whatever columns you have, and the column with the highest metric becomes your root node. Right after that, you get your splits, branches. How do you get your branches? Basically, we'll have a look while we discuss how calculation of the metric. We'll have a look at that. But you create your branches again, right? Again, in the next level, you need to figure out which column to choose. Over there, also similar, exactly the same idea. Calculate the metric for each of columns, and the column with the highest metric, right? If say consider I'm using information gain, the column with the highest information gain becomes the node, right? So when do you arrive at a leaf node, right? Obviously, you can't see, this is an iterative process. Right? Obviously, you can't keep on going. You should know basically when to stop, right? One obvious way is when all columns, right? When all values in this particular column is a single value. When all values in, say, at a particular node, everything is play, then obviously tree splitting stops. There are other stoppage conditions as well, right? So see, all of these, your decision tree, your gradient descent, all of these are iterative process. Okay, so it keeps on going. So you should basically set a stoppage condition. So say stoppage condition, nothing but your particular reasons. Say if this condition is met, stop the tree building process. Right? Similar to what you saw in gradient descent, right? If you remember in linear regression, what was the stoppage condition? Was if the gradient was very small or equal to 0, or your new value and updated value is almost the same, then you basically stop because you've reached your minimum. So I'm talking this in terms of linear regression gradient descent. So over here also in tree building process, obviously there would be certain stoppage conditions, which obviously we will look. But first, I think you should understand how do you calculate metrics, how do you calculate a gene index metric, how do you calculate the information gain metric. So in the next session, we'll basically go into that, and we'll basically understand how each of these metrics are calculated. Okay, guys, then we'll discuss it in the next session. Thank you.